Hi, my dear students. Hope you are doing well. Our lecture series regarding new syllabus grade 9 mathematics is continue the important exercise regarding probability. We will try to be our best to solve this complete by today. So let's start our exercise. So today we will solve each and every question one by one, and I hope you will get it. So in case of any problem, you can just comment on me. So let's start with the first question. Question one: a letter is chosen randomly from a word Allah. So there is a word Allah, basically a noun. Okay, now find the probability of getting. So the first part is a vowel. Okay, so you know there are five vowel A, E, I, O, U. So we have to see this. So I wrote already the formula in my previous lecture. I told about the introduction of probability. There is the formula, so you can find that, or I will give you the link in the description. So, but I wrote the formula again over there. So probability of vowel is equal to number of vowel divided by total number of letter. So what the object is here, what the anything will be here, just we will put on the formula. Okay, so these are the letters, you know, that alphabetical letters. Okay, so let's start. So number of vowels, we have to see how many number of vowels are there. Okay, so a. Is there any more? No. A, E, I, O, U. So all of us know that A, E, I, O, U. There are five vowels. So here A is used for two times. So what will be the probability? Two. So number of vowel are two, and then total number of letters. So how many total? One, two, three, four, five. So these are five. So in a simple way, we did it. So let's move next. NH. Okay. So number of H. So total number of letters. So we have to see how many H are there. So we will see when we will see the letters only one. So number of H is one. So formula is already the probability of H. So total number of letter is five. So that will be the answer. Okay. I advise you to in the exam must write the formula. Okay. So probability of an L, the third part. So number of L. So number of L are again 2. Okay. So just put the value 2 and total numbers are 5. So that's it. The next is probability of L. Sorry, it's by mistake. Probability of consonant. Okay. So number of consonant. You know, these are the vowels. Okay. So five vowels are there. Total letters are 26. Okay, in alphabetical 26 letters are there and fives are vowel, so the remaining are 21. Okay, so now we have to see that how many consonants are there. So look, A is vowel, yes, and other A is also vowel. Two vowels are there and the remaining one, two, three. Okay, you have to count. Don't think that you are counting the same number, same letter for two times. No, you have to count all the letters which are over there. So L is here for two times, no problem. One, two, and then H three. Okay, so 3 by 5. So I hope you understand this. This question is finished. So let's move toward question 2. Okay, so again, a garment factory shipped an order which contained 7,000 jackets. Okay, 2,000 sweaters and 3,000 trousers, in which 7 trousers, 5 jackets, and 9 sweaters are faulty. If the quality inspector unpack one of the item at random, find the probability at that is. Okay, so a garment factory shipped an order. So 7,000 jackets, 2,000 sweaters, and 3,000 trousers. So first of all, we have to write the total number of all the things, total item. Okay, so let me write here total items. Okay, so total items. So that will be, we have to add 7,000 plus then 2000, okay, then again 3000, okay. So now we have to add them, so that 7000 plus 3000, 10,000 plus 2000, so that will be 12,000 over there, 12,000. So in a simple way you can solve like that. Okay, so also we will see the faulty items also here. So let me write here number of faulty items. Number of faulty items. So that will be, so how many are these? Seven trouser, five jacket, and nine sweaters. So 7 plus 5 plus 9. 7 plus 5 plus 9. So that will be 21. Yes. 12 plus 9 is 21. I'm sorry. Okay, so we did it. The basic data that is given to us. Now, in the question, what is given to us? Probability of trouser. Okay, I already wrote the formula. So, in a white to in, just save your timings. So, number of L's. So, number of not L's is the basically number of trousers. Okay, so just let me. So number of trousers are there. So how many numbers of trousers are there? If you will see that 3000 trousers. So let me write here 3000 like this, and then so total number of items, or you can write like this, items. Okay, so total number of items are 12,000. So we can cancel out these zeros, and then 3 1 times and 3 4 times 12, or you can just put in calculator, so you will get 1 over 4. Okay, so that is the probability, that is a trouser. Okay, not a jacket. Okay, so when there will be a question like that, not a jacket, not anything, or not a variable, or not an object, so what happen, what we have to do? So probability not a jacket is equal to, so this formula will not apply. We will write 1 minus probability of jacket, like this. So that will be 1 minus probability of jacket. So probability of jacket is basically number of jacket, okay, divide by total number of items, or total items. So I will solve over here this. So 1 minus, so number of jackets. So how many number of jackets are there? 5 jackets are there. Probability of number of jackets are basically 7,000 jackets are there. So these are the faulty. Okay, so 7,000 jackets are there. So let's write here 7,000, and then divide by total number, total items are there, which are 12,000. You can put this calculator, you can cancel out these zeros, so you will get 1 minus 7 by 12 after cancelling these three zeros. So the answer will be, let me just solve with the calculator. So that is 5 by 12, like this. So this is the probability, not a jacket. I hope you understand. So probability of faulty items. Okay, so uh, now see probability of faulty items. So number of faulty items, first of all, right here, number of faulty item divided by total items. So I just write the formula again. So don't worry about that formula. Okay. So total items are 21. Okay. Number of items are 21, and total items are 12,000. So probability of faulty items. So that will be 21 over 12,000, or let me write with solve with calculator. So we will get in point 0.00175. So I hope you understand this question. So let's move forward with question 3. Okay, a number wheel is divided into 8 equal sectors labeled as, okay, so these are the name, so the names of flowers. Okay, so pansy, lily, orchid, or tulip, jasmine, rose, and marigold, and sunflower. Okay, so may spin the wheel once, find the probability that the pointer, so stop at rose. So there is only one rose. Okay, so if you see this, the wheel is divided into basically 8. Okay, this thing has to be noted 8. Okay, so 8 equal sectors, so each sector has an equal probability of being, okay, landed. So let's calculate the given what he asked to us. So the first thing, probability of the stop at rows. Okay, so it's basically rows is for one time, only one, and then the divide by 8. So this is basically the probability of. So the next is the probability of rows. Probability of the pointer stop at 4-letter flower names. Okay, so we have to find this. So 4-letter flowers names are, so look this, 1, 2, 3, this rose 4-letter, so let me write here 4, not 4, not 4, not 4, not 4, not 4. So this 4 and this 4, look, just I put here 4. So these are basically 2, okay. So 2 favorable outcomes are 2 and total 8. So after cutting, so 2 1 times and 2 4 times. So 1 by 4. So that is the answer. Now the third part, does not stop at marigold. Okay. So when there will be not, you will just do 1 minus the probability of marigold. So marigold is here for one time. So 1 over 8. It's basically 1 minus probability of marigold. Yes, like this, probability of marigold. So 1 minus 1 over 8. So we'll just solve with the help of calculator. 8 1 times 8 minus 1. So it must be 7 by 8. So this is done. So now move toward the fourth question. We have to find stop at 3 letters flower names. So 3 letters flower name. Just find this. So no 3 letter, no, 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 again no. So there is no any. So favorable outcome is 0 and total is 8. You can write directly. So it is 0. So this probability is 0. So stop at a flower's name. Okay. Stop at a flower. So he's asking flowers. So this is a common name. So how many are total? Favorable outcomes are 8 and divide by total. So that will be 8. Okay. So 8 divided by 8, that will be 1. So I hope you understand this question. So let's move towards the next. The fourth question is in front of us. Okay, so this is interesting question and very easy. Okay, so a decagonal die, decagonal mean having 10 sides. Okay, so you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so these are the 10 is rolled ones. Find the probability of getting 4. Okay, so probability of getting 4. So number of fours, basically number of fours are, okay, so simply number of fours, just count the number of four. 1, 2, 3, 4. So these are 4 and the total number of fours are 4 and the total number of outcome is 10. So let more simplify. So 2 by 5. So probability of getting even numbers. So even numbers are simply the number which are divisible by 2. So this is divisible by 2, this also, this also. So these 4, 5, 6, 7. So these are 7. So 7 and total number of outcomes, so 10. Okay, 10. So I hope you understand a very simple. Then move next probability a multiple of 4. Multiple mean it's just like a timetable 4, 8, uh, 12 like that. Okay. So this is also a multiple. Okay. So 1, 2, 3, 4, 5, 6. So these are the 6. 6 over 10. So you can cancel out or 2 3 times and 2 5, or you can just solve with the help of calculator. Okay, not a 7. Okay, so probability not a 7. 7 is here for how much time? Only one time. So how you will solve? 1 minus probability of 7. You will put like that, and then 1 minus probability of 7 is basically 1 over 10, because 7 is here for one time. Okay, no confusion should be there. So you can just put in the calculator, so that will be 9 over 10 like that, or you can take LCM. Okay, so the next part is fifth part is so the fifth part is here. You can see the question from your book or anywhere. So stop at flower's name. This has done. So this has done, and then okay, fifth part is basically an odd number. Okay, when you see this, so is there any odd number? So look, 5 is also odd number. This 5, 7. So how many odd numbers are there? So when you will see that there are basically three odd numbers. So let us write over there. So three odd numbers are here. So 3, and the total numbers are 10 like this here. Okay, a prime number are basically, let me explain, a number which is divisible by 1 and itself, exactly having two prime numbers. Let me write here just for information. Prime number which has exactly two different divisor. So it start from 2. Okay. Look, 1 has only its one divide 1. Who divide 1? 1 only. But I'm saying two different divisor. Who can divide 2? 1 and 2. So these are the two different divisor. After 3, after 5. So these are called prime numbers. Okay. So how many prime numbers are here? uh, 5, 5 and 7. So total prime numbers are 3 prime numbers basically. So a prime number basically 3. So we will write 3 favorable outcome divided by total number like this. 3 by 10. So LCM of 4 and 8. So it could be it could be difficult for some student, but it is not difficult. So LCM of 4 and 8. So LCM mean least common multiple. So least common multiple. So let me write for 4. So 4, 8 like this. Okay, 12 and so on. And for 8, let me write 8, 16, 32. So these are the multiple. So what is the least common? So this 8. Okay, so only 8 is the common multiple. Okay, so probability of so 4 and 8 is basically 8. So let us write this 8. Okay, so 8 is here for 2 time. Okay, so 8 is in the question for 2 time. So that will be 2 by 10. So after simplifying, it will be 1 by 5. So like that. So I hope you understand. Now, HCF of 4 and 8. So basically, first of all, you should know what is HCF. HCF means highest common factor. Okay. So highest common factor of 4 and 8. Okay, who can look 4 for 4? Let me write the HCF factors of 4: 1, 2, and then 4. Okay, then for 8, 1, 2, 4, and 8. These numbers are the factor of 8. These are the factor of 4. So which is the highest factor? Okay, that we have to tell. So highest is HCF. Look, this is 4. Okay, so 4 is the, and now we have to see 4 is here for how much time. So look, when you see this, there is 4. So 4 is here for 1, 2, 3, 4 times. Okay, so in this way you can understand. So how we will write here: 4 favorable outcome, total is 10. So then you will simplify 2 times, and 2 5s are 10. So that will be 2 by 5. And then factors of 12. Okay, the factor of 12. Factor of 12, it's a simply who can divide 12? 1, 2, 3, yes, 4, yes, 6, and then 7, 8, 9, no, and then 12. So this number is not included because we have only single digit number. So now we will see which number. Let's move toward the question. So we have only factors in factor of 12. Basically, 4 can divide 12 here, and then look this. This 4 can divide 12, 6 can divide 12. So how many are these? 1, 2, 3, 4, 5. Okay, so 5 number can divide 12. So let's make the answer here. 5 divide by, so 5 is favorable and 10 total. So 5 one time and 5 two times. So that will be 1 by 2. So I hope you understand this question. So let's move toward the next part. The fifth question is there. A one digit whole number is chosen. This question is important question for the paper point of view. A one digit whole number is chosen at random. Okay, one digit whole number. So basically all the students should know one digit number are which number. Okay, so first of all let me write the one digit number here. So these are 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And after 9, the two digit number will be started. Yes. So these are the one digit number. So how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are 10. So let's start the question. He's asking. So we'll try our best to make this question easy, very easy. Okay, so probability less than 5. Okay, so less than 5 are how much? Less than 5, 1, 2, until 4. Okay, 1, 2, 3, 4, 5. So 5 divided by 10. So that will be 1 over 2. Okay, and the next is greater than 10. Okay, greater than 10. Do you think that is there any number greater than 10? So there is no number which is greater than 9 as well. So favorable outcome 0, total 10, so that will be 0. The third part, not uh, not the largest one digit number. Okay, not the largest one. You should think that not the largest one digit number. Who is the largest one digit number in this all? See this very carefully. So obviously 9 is the largest one digit number. Okay. So 9 is the largest one digit number. Okay. So he's asking not the largest one digit number. So then the remaining is the so if I will cut out this 9, so the remaining will become 9 digit from 0 to 8. So that will be 9 over 10. Okay, so this will be the answer. Okay, now additive identity of whole numbers. Additive identity. Additive identity is basically the number which if we add that number to any number, so it basically the number will remain same. No change will happen in that number. So that is called additive identity. Okay, so it means additive. So we have to add that number. So what that number? So obviously 0. Okay, so how many zeros are there? Only one. One is the only additive identity. Okay, so probability of that, you can write also here probability of that additive identity, okay, will be 1 by 10 because there is only one number. Okay, so I hope you understand this question until that part. So let's move toward, there are also other parts are there. I will explain one by one, then I will solve. HCF of 3 and 5. Okay, so first of all, let me clear this. HCF of 3 and 5. Okay, so 3 and 5, highest common factor of 3 and 5. So if I will write here 3, so who can divide 3? 1 and 3 factors, so these are the factors. And 5, who can divide 5? 1 and 5. So what is the highest common? Only 1. So 1. So 1 is here for how much time is there in the question? So only one time. Okay. So that will be the answer. Okay. So 1 divided by, so probability of, you will write HCF, okay, between 3 and 5, 1 by 10. So I hope you understand. Now, multiplicative identity of real number. So first of all, you should know the multiplicative identity. Okay, is basically the number which we multiply to any number, so it remains same. That will be multiplicative identity. Okay, so multiplicative identity is basically 1. If we multiply 1 with any number, so no change can happen to that number. So then what we will write over there? So we will write multiplicative identity is only 1. So probability of multiplicative identity is equal to 1 over 10. So I hope you understand this. Now the seventh part, not a prime number. Okay, so this in the exam they will ask any two or three part, not all part. Okay, so you should be ready. Not a prime number. Okay, so which are not a prime number? Okay, first of all see that which are not prime number. So let's move toward the question. So 0 is not a prime number. 1, okay. 1 is not a prime number. 2 and 3 are prime number. 4 is not a prime number. 6 is not a prime number. 8 is not a prime number. So how many are these? 1, 2, 3, 4, 5, and sorry, 9 is also not a prime number. 6. So basically these are 6 number. Okay, so let us write the, so these are 6. Favorable outcome, probability of not a prime number. Okay, so 6 over 10, 2 3 times and 2 5 times, so that will be 3 upon 5. Okay, that factor of 9. Okay, who can divide 9? So let's move toward the question again. Who can divide 9? So let me write here 1, 3, and 9. Okay, so all these are present over here. Okay, 1 also present, 3 also present, and 9 also present over there. Okay, so basically these are three numbers. So let us write the answer of this. Probability of factor of 9, that will be, so basically these are 3, so favorable, and then total is 10. So until here I hope you understand. uh, Question, so that question was question 5. Okay, so the next question I will solve in the next lecture. So until that, you can ask any problem that you are feeling, just a comment and I will reply.